Thank you very much for your time and for participation in the first mepaia webinar. The idea is that we organize a webinar for all our features and to deeply try to explain all the functions and all the things that we did develop together with that function. Today we have pressure drop calculation, and the idea for this webinar, probably for the webinars that will come, is I will try to present everything I can about the feature in the 45 minutes, and then we will spend like 50 minutes for questions and answers. You have a section Q&A over here in this call, but you can also type your questions in the chat, and then when I finish with demonstration, I will get back to the questions. Also, we will record this meeting and we will publish it on the YouTube, because I think you will have a lot of information at once, and maybe at the time when you want to try this feature, I think it is good also to have recording nearby and to check all the features that we can do. Right now we are talking about pressure drop calculation. This week, at the end of the week, we will also have new release of mepaia, and we will have new function or calculation, which is heat load calculation. Also, we are working on the cooling load calculation, and this is very much important for us, room-based air volume calculations, because in order to determine the air volume for each and every room, you need like 3 criteria: heating calculation, cooling load calculation, and also air changes of volume for that type of the build, for that type of the room. So we will vertically integrate a lot of functionalities with this calculation. And also, when you finish air volume calculation, that is a good input for automatic placement of air terminals on the ceiling. So in September, we will have a lot of new functions. And right now, you can try this tool. So first release of mepaia was in April, 9th of April. So for the past couple of months, we are developing new tools and also improving the existing ones. Pressure drop calculation was released in that first release. And also Marco is on the call. Marco is the one among the first test users of the tool, and he also did provide the feedback, which we did integrate in the future releases. And once again, Marco, thank you for that. So on our website, you can see more about the company roadmap, the things that we are developing. You can also try this tool for free. You can also click over here and go over here. So you have 14 days of trial without any limitations. So there is no any watermarks or some limits in the number of pages for the report or anything like that. Everything which I showed today, when you test the product, you will also be able to do it. Just about myself, in 2 sentences, I'm Nenad Kovacevic. I'm a mechanical engineer, finished studies in 2013 here in Serbia, in Belgrade, thermodynamics department or HVAC department. From 2013, working as a HVAC designer, BIM coordinator, BIM manager, also have experience in the construction, following the construction sites as a BIM manager, and also from early moments when I start working as a HVAC designer, every time when I need to do the same task over and over again, I did try to improve it a little bit, to make some automatization about the task, so next time I can do it a bit faster. And that was like push for me to start with Dynamo, to start with Python, to go to some Revit small add-ins. And now I am in Anwar Software leading our development team in effort to create really MEP AI assistant. And some just general thing about the pressure drop calculation, and then we will go to the Revit. There is not slides anymore. So because we are a new company, a new team, we did set as a goal to start this new tool with support of Revit 2025, 26, and 27, because there is some .NET architecture that are you can go smoothly from here, but it's a really additional effort to support Revit 23, 24. So we are supporting Revit from 25 to this current 27 version. For the tables, for the fittings, which is like the core of this calculation, we are using handbook, their climotechnic tables and also ASHA tables. And you also have a possibility, I will show that, even if you have some very custom fitting for which maybe you will spot that mepaia didn't set that local coefficient for the pressure drop correctly, you have an option to check manual parameters for the K or zeta values, and then you will enter it yourself. And we did set a goal not just with this calculation, but for all our calculations. mepaia must work with all Revit families. It should work in all like design bureaus, so we will not give you with our tool some custom special families that you need to use, because that will require that you change a lot the workflow that you already have. So there is not special or custom Revit families. mepaia will work with all Revit families, and there is not any system requirements in a way. I expect that you disconnect everything, that you set what is the start and end point. Everything should work smoothly if we set some input correctly. I will also show that. And yeah, we do support metric and imperial units, and we do export report in 4 different languages: English, German, Spanish, and French. And okay, if some other localization is needed, that also can come from you as a feedback, and then we will include it. And yeah, we also, because Anmar as a company, it's a design bureau, and we are also using the pressure drop calculation, and we did use it in the past, or every time we did have a little of manual works that we need to do alongside with a calculation report in order to get the image and critical path and so on. We did try to integrate all of that, so when you generate report, you should have everything. And okay, that is like what is the general topic. Now, I will show you some real projects, some real system, and some problems that occur when you stepping into the real project, because at the end, mepaia should be able to help you from the beginning of the project until the drawings. Also, we should handle the routing and everything. And when we come at the place when we will do everything, insert the elements, give you the route of the ducts and everything else, then we will make sure that everything which is required for this calculation will be correct. But until we come to that point, which is something which we will face, I hope, by the end of this year or beginning of the next year, then I need to show you what will be the real usage of the pressure drop calculation on your real project. So I'm over here on some project where we did have 40 different air handling units, and we did successfully calculate the pressure drop for all of them. If you just installed the mepaia on a try version, you will have mepaia on 2 different places, on your desktop and also over here in the add-ins part of the Revit ribbon. I suggest that you start mepaia over here, because if you start mepaia before you start the Revit, mepaia will say, okay, you did start mepaia, but you didn't start the Revit, and it cannot connect with the Revit. So yeah, you can start mepaia from here. When you start mepaia, we have a lot of different features, and in the future webinars we will talk about them. But when you open our GUI, our graphical interface, you will usually start over here into the voice to command, and then you will need to switch over here to the pressure drop calculation. What is very important for me to say, even though mepaia it is MEP AI assistant, over here for the calculation, for this calculation and also for the others, there is not AI. So calculations are fully deterministic code, basically. Why? Because for this system or for any other system, you should be able to run the calculation for that system, and always you must have the same results. So that is why there is not AI, there is not hallucination or anything. And also when you click over here, calculate pressure drop, everything which you do will be done on your PC. You're not sending any data, any project data or anything. So we are not calculating the pressure drop on some our server and we are returning the results. Everything is happening on your PC. And you will also notice that when we start with the generation of the report, that is that will buzz a little bit fan on the hardware side. So you will actually have impression that things are done on your PC. So over here, as I said, we will start on some real project. And over here, I did fix a lot, some things, but a lot of things I didn't fix intentionally in order to show you what you will need to have as at least some minimal input in order to start with pressure drop calculation. And the things which you will often have are elements are disconnected, or there are some special families that you needed to do in order to perform some other calculations. We are expecting that when you start with the calculation, everything must be connected. And of course, if you also have the situation where maybe you didn't connect yet some air terminal, we will also detect that, we will report, we will give you a feedback, and you must fix things like that in order to start with calculation. So on top of everything which is a problem over here, I also deleted air terminal just to show you what will happen. So, and we have a trillion of things. I will try to compress it in those 45 minutes, but okay, we will see how it goes. So I did start with the pressure drop calculation, and I will unlock these things for you one by one. But for now, let's just go with first option that you want to click on the air handling unit. mepaia should recognize everything, and it should calculate the pressure drop. Let's click OK. mepaia says, OK, click on the start element. We will click, and then we have a pre-check. So we are checking a lot of things in order to validate that you have good input and that we actually can start with the pressure drop calculation. If the case on your side is something like this, you will need to fix a lot of things before, when you have all those checkbox marked green, then you will be able to continue with the calculation. If anything is red, you will not be able to continue with calculation. But I will show you also that we have some tools in order to help you at least to find those elements and to fix them quickly. So over here, because you cannot proceed, we can click cancel. And over here we have now just a report with all the IDs grouped in the some problem types. So you have one element which is not connected. That is probably that diffuser that I just deleted. You have a lot of elements for which we do not know airflow. If you did design any ventilation system in the Revit, you know that we have a lot of trouble with this one. A lot of elements just does not contain pressure drop information. Over here, it is very important for me to say, because we did receive that as a question, what do you expect to have as a parameter name in order for mepaia to recognize the pressure drop? But we didn't go like that because, you know, on English pressure drop, it's a pressure drop. On German, it is something else. On, I don't know, Serbian, it's something else. So we cannot basically took the name of the parameter. Wow, I did zoom my camera. It is some automatic camera. Okay. So you cannot took parameter name as an input of the pressure drop. We are basically searching for each and every element parameter type. And if parameter type it's a pressure drop, we will take it. But for a lot of elements over here, we do not contain pressure drop parameter. And we have on some system wrong connection. I will copy this for a moment. And we will try to resolve this one by one. I will show you this is not, it requires sometimes, but it's not such a big thing. Okay, let's start with the first thing. Something is not connected, but we have element ID to the closest element. So if I now go, I have the shortcut, but just I will show you from the ribbon for the first time. So select by ID. I will type this ID. And what is the element which have not connected element? It is this one. And it's natural because I did delete this air terminal, and mepaia reports that we have over here some things which are not connected. I will undo this one. So let's say that we did fix that right now. Let's also check this one. no pressure drop and no flow, it's a bigger issue, but this wrong connection, let's see what is the problem with that. So we have, and basically those issues, because I did check this before the webinar, we have basically on the return system, air terminals, which are exhaust air. And for Revit, that is not okay. So in supply system, which is this magenta color, everything must be supply, all duct accessories, or air terminals. Same for the return system. All duct accessories, all air terminals on the return system must be in system classification return air. Over here, mepaia did recognize that we have an issue with two air terminals which are exhaust air. We need to fix that, and then we will run the calculation again. And let's quickly just resolve this issue. Just also to show when we run it again, mepaia will find that there is not issue. We do not have issue with that anymore. So for me, easiest thing to do over here is just to disconnect them. Not that. Because over here, when I did disconnected, filter will turn off their visibility. So over here, I can see that those air terminals have 600 cubic meters per hour of the flow. Now, when I change air terminals, what Revit will do often, it will reset that flow. So when I took now return family, airflow it's 0, so I need to move it to the 600 cubic meters per hour. I need to connect them. And because I did push it 50 millimeters down, I will now return it to 2.8. And I did turn off all filters, so I need to turn them back. And okay, we did fix that issue. We did fix that issue, and we did fix the issue with connectivity. Let's run the mepaia again just to see if anything changed. So we have still an issue with the airflow presence and pressure drop assignment. Let's check what is the problem with airflow presence. And then because those information, when you have 0 as a flow somewhere on the network, that information will pass. So over here, we see that basically immediately after the air handling unit, because it is a supply, we have 0 as a flow. So we have somewhere during the network issue with the flow, so we can follow the network. And usually I'm looking at the velocity. If the velocity it's okay, I know we do not have problem in that direction. So over here it's a 0 for the flow. Over here we have 650 cubic meters, but the velocity is 0.2, so still this branch is missing some airflow. Still less than 1 meter per second, and we are coming basically to this point over here. So the issue which I saw the most so far is those multi-port fittings, which actually should sum all the airflows which you have in the different branches of the duct. So if we look over here, we have like 1,000 of cubic meters, 1.8, and 2. So like we should have as a sum 5,000 cubic meters, but we have 0. So definitely the issue is in this multi-port fitting. And now we can discuss a lot about how this multi-port fitting and those connectors are set, but what you should do over here, because in this project multi-port are used on the return side and on the supply side, we must put them to be a global, bidirectional, calculated. So basically the airflow will just go through the multi-port fitting. So those are all the, I would say, Revit issues that mepaia helps you in a way that it gives you a list of ideas, but we do expect that you did prepare entire HVAC system in a way that everything is connected and the airflow it's good in all the parts of the network. Okay, I think that we also did fix that one. So now if I start calculation again, so the things which is missing is pressure drop assignment. And for pressure drop assignment, over here we have a tool, enter missing pressure drop values. So over here now we will list all the elements for which we cannot find the pressure drop information. Either you have a parameter, but the value on that parameter is 0, or you don't have parameter at all. And now this is the pressure drop mapping tool that we have right now, but it will be also improved in September, together with that tool, which will automatically place the air terminals on the ceiling. But what you can do over here, so now there is not shortcut. So you must use your selection software for the air terminals and duct accessories and mechanical equipment, and you must enter the data for the pressure drop. You can do it in your parameters, but you can also use this tool and go row by row and enter the data. If you are saying, okay, but I just want to quickly use this tool in order just to assess what is the pressure drop, and it doesn't matter what pressure drop I will have on devices, you can use this bulk pressure drop. You can select all devices, give some value, and you can go further, but that is not, it is not a good thing. It is maybe good for some rough assessment of the pressure drop, but you really need to spend time over here and to fill all those pressure drop parameters for your equipment. I will just quickly show what we are developing also right now. This is just work in progress, just so you can have impression what in which way we are going. So the thing which we do must support pressure calculation. At some point we will also do the noise calculation, but also this airflow calculation for min and max values in order to assess how many diffusers, for example, you need to have in some room. And over here, even for the same type of the equipment, now you also have the airflow, and then over here you can type for each and every airflow for the same device what will be the pressure drop. Also, we are spending some time and talking with the manufacturers in order to try to help the users where we'll try to detect what is the type of this air terminal. We will have some catalogs in the background, and we will give the user estimation about the pressure drop and the noise for different octaves and so on. So we are spending some additional effort over here because we did realize, even though this pressure drop calculation improves the speed overall in this calculation, but this is the point where you need to enter a lot of pressure drop data, and we also want to improve that one to be even faster. So now we did fix everything, and now we can start with the calculation, but also for the fresh air over here, we have basically the shared system of the fresh air for different air handling units. And over here, I will show you how you can basically overcome this problem and to just took the part of the network which is suitable for that air handling unit. But over here, some elements are disconnected. And from here, I will just go to the result project where I did enter the pressure drop information and I did connect everything. And then we will start playing with the pressure drop in that, let's say, finished project or setup with all the inputs. Okay, this is the family which we did edit. Okay, now this is the same system basically, but I did go through the that pre-checklist. I did fill all the data, and for this fresh air, I did leave only the part which is related to this air handling unit. And now we can actually play with the pressure drop calculation, and I can show you all the things which we did develop. So now if I say calculate the pressure drop, so the thing which I did show you previously, you can just click on the air handling unit, and the idea is everything is connected, airflow it's okay, mepaia should recognize everything, and it should done the calculation automatically. That is the one way, and that is the way that you will use probably in the 99% of the cases, but it can happen that maybe you just want to check supply part of the network, or just return part of the network, or just fresh air. You can also do that with the same option. So you can just click on the calculate on every route. It will ask you for the start element. And now if you just want to complete the calculation on the supply air, you can click on any supply air element. and then the system will say, okay, the user just click on the one system, we will need to calculate the pressure calculation for that system. I will recognize all the elements. I will know from what is the start point, what are all the endpoints, and I will calculate the critical path. So that is the idea over here. It did go the pre-check, everything is okay, so we can click OK. Once you click OK, generation of the report will start. That is something which takes some time because we are searching for each and every possible route. We are going from the source to each and every air terminal, and we want to show in the report each and every air terminal. So sometimes you will have like 300 pages, sometimes you will have 150 pages, but it just takes some time if the system is big. For the folder where you want to store the report, we did set up in a way that we should always offer a desktop as a folder for saving the report. And once you click the save, that report should be automatically open. So over here, I just did click on the supply air, and that is the thing which we are calculating right now. So supply air, we have some basic project information which we are reading from the project information in the Revit, and we will talk about absolute roughness, how to set it, where is the settings, and so on. Information about the supplier, and over here, because I said we are calculating each and every route, so over here S15 is a critical route. But before we check that, so mepaia will automatically place the image that will show the critical path. Also, we are saying that if you are in the 3D view, we will do some post-process. We will zoom out, create a snapshot, and place it in the report and exit. But you can also be in any basically view if you want. If you want to create this image from the floor plan, you can also be in the floor plan. Over here, either I forget to save or I forget to set up. Yes, sorry, I did forget to set up view template, but you can also insert the image automatically in the report from the floor plan. So basically, where you are in the moment where you are click on the calculation of the pressure drop, that view we will use in order to create a critical path. And this is the example for the supply air. We can also just check on the report that S15. No, I did copy that ID from previously. So S15. So we will display all routes basically from the air handling unit to the each and every air terminal. But up there in the information we did have that S15 is a critical one. That critical route will be colored in this red color. And we want to be absolutely transparent about the elements and about the conditions that we have for different elements. So the first column in the mepaia report, it's a Revit ID. So now if you are reading the report and you are seeing some values for which you are not sure if those conditions are really in the Revit, you want to check something, you can just grab any ID and you can go to the Revit, you can search for that element and see what is the issue with that element. So we are trying to be maximally transparent about the conditions and the elements that we have into the calculation. Also, we did have a question a couple of times, why near to the Revit element ID we have 1, 2, 3, 4. That is actually the thing with tab. So if you have a duct and you have a T fitting in Revit will basically split the duct into the two ducts. But in the case when you have a tab on the duct for a Revit, this is one big element. It is not splitted in any way, and because we need to calculate, basically, if we are calculating to this air terminal, we need behind in the calculation to split this element into the two, because I don't know the length of this element. It's 11 meters, and we will say okay, because we have tab over here that is a 9 meter, and over here we will have 2 meters, and I don't know what is the ID, but whatever its ID. For us, this is a 0, and this element ID is with a 1. If we have multiple tabs along the way, we will split virtually, let's say, this element into the smaller ones, because the length before and after the tab, what is very important for us. That is why near to some element IDs, you will have -1, -2, -3. And that is the case when you just wanted to calculate one system, and you also have a possibility to say, I just want to validate maybe some part of the network, so I want to go from here to here, whatever is from here to here, and you can use this function. What is very important for this function is to follow the air, because also you will see in the report, in supply, we are going from air handling unit to the air terminal, but for the return, we are going backwards. We are going from air terminal to the air handling unit. So if you want to use this feature from start to end, you also must follow the direction of the air. So let's also try that for the return air, for example. So I want to use this feature. I will click OK, click on the start element. For example, it can be this one. We can now go to the air handling unit, but it's also not mandatory. You can stop just to not miss the branch. For example, I want to stop over here. So now we'll find all the elements along the way. Of course, now you did choose one air terminal for start and end, and that will be the, let's say, the critical path. So basically your selection. But for that selection, we have all the information. We did find the airflow, we did calculate the pressure drop. And because this is just the route 1, because that is what is our selection, now we have information for that one route. Okay, now regarding the fresh air, we did also try to cover a lot of things, as I said. So if you have makeup unit that will make a cover up for the fresh air on that air handling unit, so that is not the pressure that you need to overcome with your fan, then you can say, okay, I want to calculate the pressure drop for this entire system, but I have a makeup unit. And of course, for temperatures, because temperatures will influence the density, everything which is dependent on the density, you can also change. So for example, supply is 70 degrees, and you can also change the rest of them. And it will affect, of course, the calculation. So entire system, but we have makeup unit, okay. And we'll click entire air handling unit. And again, it will take some moment for mepaia to generate the report. And the other option is, as we did so previously, when there is a shared network for fresh air, you can just set, I have a plenum box. From here, I'm calculating that I have 50 pascals, and the calculation, it will start from the selected element. I will also show that just for this one to finish. Okay. So fresh air, it's not in any color. And because we did click, I have a makeup unit, we have supply, return, and exhaust air, but we do not have fresh air. And we did try also to understand a lot of different combinations. So in case when you have a supply and return, which is driven by the one fan, it will be fan 1 for the external pressure and things like that. So all the information that you need should be presented over here on the cover page. Again, the image with the critical path, and again, entire list of calculation for all paths for each and every element and things like that. So that final option with plenum box, and every time when you, because over here we will set the colors. If you, this is, I think, okay when you're calculating the pressure drop and you want to see the critical path. But if this is some working view and you just want to reset the colors, you can just start again pressure calculation. It will automatically reset the colors, because maybe you now did change the pressure drop on some elements, and now the critical path, it will be some other path. So, okay, let's again use the air handling unit for calculation of everything. But over here, I will say I have a fresh air as an intake plenum. So, we will just, now it's just very important that you follow over here what we are asking. So at first we need to select the element from which we will recognize all the system, which is either some system or its air handling unit. And now you should click on the element which we will declare that is a plenum box. So this one. And now, because you will say, okay, this is a plenum box until here we have 30 Pascal, 50 Pascal, 70 Pascals, whatever. From that, it will start the calculation. Over here, now we need to set what is the pressure drop from that plenum box to the air handling unit. And now we will have all systems. So one fan, it should be the fresh air and supply, and the other fan, it should be return air and exhaust. And is taking, I didn't show you, but so in this case, when we didn't have fresh air, we have 339 pages. So it takes some time for a report to be generated. And after this, I will just go through the MEPia settings for pressure drop calculation. And after that, we can start with the Q&A. If you already have some questions, you can type it so we can go through them when we finish with the settings. Okay. Either this is, okay. So, okay, I will start this one more time. I have a fresh, okay, I will explain what did happen. This is to recognize the system, 50 Pascals. So MEPia, it's actually two-part system. One thing, it's our GUI, it's our graphical interface in which you will pick the feature, and the other thing is the part in the Revit which actually need now to find all the systems to run the calculation and everything. We did set some time between regarding the communication between these tools. And now what I did probably do, I did lift the feature and I then did explain for a minute or two, then I click, then I explain something for a minute or two, and we did breach basically that time in which our application did require the response. So now I did quickly click to recognize the system to enter the plenum box. And now, yeah, so and now everything is finished. We do not have this response timeout. So right now we have supply, fresh air, return air, exhaust air, fan 1, fan 2, all the information, critical path for entire system, and of course, all the information regarding each and every of those systems. Because when you collect the data from the Revit, if you just run the calculation 2 times, you can say, okay, but Nenad, for the first time, the critical path was S23, and in the next time it's S25. That is just a matter of how we are collecting the data from the Revit. It is always the same element in the Revit, but that same element, when we did collect it from the Revit, sometimes appeared on the 12th index, sometimes appeared at the 100 index. So it is the same element, same pressure drop into the decimal. So again, no AI over here, no hallucination. We did triple check that. So just this, what is the critical path, and the number depends on what is the collected element from the Revit. And now regarding the settings, so over here into the add-ins, we have MEPia settings. And the first part of MEPia setting is related to the pressure drop settings. So as I did say, for example, and we can also check that, if we go to any element, it is some elbow, for example. And okay, you did check that in report, but over here, that is a very some special fitting, and our zeta or K value for this one, it's not correct. What we can do, we can go to our settings and we can say that we want to include this by default. It should be turned off, you can turn it on, and then parameters will appear over here. And we want to foresee basically the most complicated thing are the T, because T and the tab have the run and the branch. But when you're creating a parameter into the Revit, you cannot you cannot create sub decisions. Basically, you say this parameter will be for the entire duct accessory. So over here, of course, for elbow, you will say, okay, for this elbow, what is the current value? 0.9, I want to be 1.2, for example. And now, because you did turn on these custom parameters, next time when you run the calculation, we will check, did the user start these custom parameters? Yes. Did user for this fitting enter the value? Yeah. So that will be like the top priority for our calculation, and we will respect that. So for this fitting now, we will ignore our tables, and we will continue with whatever user specified over here. So you can do that. That is the one thing. The second thing is we are respecting some academic, basically, publishment. It is not a standard. It is basically a correction of the flexible ducts based on the imperial data and testing into the lab. Basically, what we are talking over here is during the construction, you will not have almost never fully stretched flexible duct, and because that flexible duct, it's usually, it's supposed to be like 1 or 1.1 meter, but it's 3 meter, and then you did reduce basically the diameter for the flow. With that, you did increase the velocity. So actually the pressure drop into the flexible duct, it will be 4 to 10 times bigger than what you're calculating with the ideal conditions. Generally in calculation, you will have in critical path 1 flexible duct. So even if you say do not use it, or we have good conditions on the construction site, okay, I can respect that, but we just want to improve it a little bit and to foresee actual problems which you will have during the construction. Over here, of course, for ducts and also for the flexible ducts, you can choose if you want to use first, second, or third option for the equation by default, because it's more accurate. The most accurate, we will go with the Colebrook equation, but you can change. Regarding the material and roughness, that information, which is very important, and it's on the cover page on the report, you can determine the roughness either by material. You will just change the material, and next time when you run the calculation, we will take that material to be material for the ducts. Or if we didn't foresee some material, you can type it over here. And then again, next time when you run the calculation, we will take whatever it is written over here. Regarding the report settings, you can also include your logo image. It will be next to mepaia. And as I said on the beginning, we are supporting 4 different languages for the report. And also on the report, we are respecting metric and imperial units. And finally, for those colors which we are seeing when we calculate some system, you can change that. If you want to say, okay, for supply, I don't want blue to be a critical path, I want to be something else, you can change it. Next time when you run it, the tool will respect your colors. And okay, I'm perfectly on time. So if you have any question regarding the tool, you can ask now. Or you can type it, or I just think if somebody have a problem with the mic, or if there is not question, that is also okay. But if you have also some issues with the sound or anything, you can type. Marco is typing. If you spot also any problems or difficulties while you're testing, your feedback is pressure for us. So I just encourage you to download the free trial to try the tool. If you have some cases which we didn't foresee, just let us know and we will try to respond as soon as possible. Okay, Daniel is also typing. Aha, I think I did. Sorry, unmute. Sorry for that. Yeah, I think it's on your side. It is allowed to be unmuted. I can either disable or enable mic, but I cannot unmute you, basically. One question, AirThermal should have the drop pressure database with the different flows. How we can manage AirThermals with dampers on it. Okay, for the first question, so air terminals should have a pressure drop database with different flows. So right now we are saying if you download right now the trial version of mepaia, you will need manually, as you did so far, to took some selection software for your vendor for air terminals, and then you will type what is the airflow, and that for that airflow, for that type of the air terminal, you will see what is the pressure drop and noise if you're also doing the noise calculation. But we are also working on that to bring those catalogs to the users and to try to maybe automatically took the information for the pressure drop for air terminals and for the duct accessories, but also what we will possibly do, we will do that for one manufacturer. It will be also then a question if that manufacturer is something which you're using also on the regular basis, or you are going with another one, and then you will again need to manually enter the data. But I think that next device mapper will be faster, and it will be able to at least give you proposal for the pressure drops for duct accessory, mechanical equipment, and air terminals. I think that with that I did respond to that question. We have a situation that we have two phases ducted. First one. With two or more phases, I think that is a Revit issue when you have some part of the network in the one phase and some part of the network into the other phase. I know that in that kind of situation, Revit will just declare some phase to be to have an airflow 0. That is something which we didn't foresee. But I did wrote it down. I will see what we can do over here. I think that at some point when when this feature with automatical placement of the air terminals comes in September, I don't need anymore to rely on the Revit data and what the user type as an airflow onto the air terminals, because I did go to the table, basically to the calculation for the airflow per room, and I know that for some room I have 2,000 cubic meters per hour, and then I did decide, or I did propose to the user that for 2,000 cubic meters we need to have 4 diffusers, and now mepaia knows what is the airflow for those devices. But until then, yeah, we will need to read the airflow from the Revit, and I know that when you're using phases onto the same duct network, it can be an issue with airflow. And without airflow, you cannot run the calculation because we do not know the velocity. We cannot. There is not sufficient input to start with calculation. Okay. Is there any other question? I assume no. Also, if you or if anybody have a question and is watching this on the YouTube, you can always contact us. You can go to the website. There is a contact form. And yeah, if you face any problem or you have an issue or you have some idea how we can improve this product, everything is highly valuable for us. With that, I want actually really to thank a lot of you for attending this webinar, and I hope that I will see you also in the next webinars. Have a great day, everybody.